Now let's deep dive into the Docker engine room more. So let's look into the some of the pipelines that connect each other and how that pipelines work. Okay, so the Docker daemon is the hub of your interactions with Docker, and as such is the best place to start gaining an understanding of all the relevant pieces. It controls access to Docker on your machine, manages the state of your containers and images, and brokers interactions with the outside world. So that's what the Docker. So now we'll look into the exactly how this Docker daemon does all these things. So so that is a daemon. Basically, in this case, a daemon, the Docker daemon, a daemon is a process that runs in the background rather than under the direct control of the user. A server is a process that takes requests from a client and performs the actions required to fulfill the requests. So daemons are frequently also servers that accept requests from clients to perform actions for them. So the Docker command is a client. So the Docker command itself is a client, and the Docker daemon acts as the server doing the processing on your Docker containers and images. So let's look at the couple of techniques that illustrates the Docker effectively runs as a daemon. So the daemon, so and that your interaction with it using Docker command are limited to simple requests to perform actions, much like interactions with a web server. So the first technique allows others to connect to your Docker daemon and perform the same actions you might on your host machine. And the second illustrates the Docker containers are managed by the daemon, not your shell session. So, although by default your Docker daemon is accessible only on your host, there can be a good reason to allow others to access it. So you might have a problem that you want someone to debug remotely, or you want to allow another part of your DevOps workflow to kick off a process on a host machine. So a Jenkins server or a colleague's host, or somebody you want somebody to access the your Docker, and you want your Docker to be accessed by the somebody's user, some other user. It could be a Jenkins server to automate the process, or it could be a colleague's host to do the debugging, whatever it may be. But that's the second way of doing. But first, let us look into the first part, the first technique. So how they communicate, then we will get into the second technique. So in first technique, it is pretty simple. A Docker client, that's your Docker commands, and a Docker daemon that we have seen, the Docker directory, and it's a process which is running. When I say Docker systemctl status Docker, we're going to see Docker daemon. I'll show you. So then how these two are connected? Yeah, we know that a RESTful API HTTP request, that is fine. That is fine, bro. That is not the issue here. I'm asking what utility, what is making them to connect? There should be some utility, yeah, some tool, some tool, na. What is that? That's what I'm asking. I'll show you now. Okay. Yeah, I'll make it no, it becomes smaller, dude. Yeah. mm, much smaller. mm, yeah, this is fine. Okay. So sudo I clear the screen. So now let's see what is Docker client. So Docker client are our commands. So Docker, it's done. So you've seen the Docker client. Now let me show you Docker daemon. System ctl status docker, because Docker is a process. Docker daemon is a process. You see that? Docker dot service, a Docker application container engine. You see, Docker engine. And it's loaded from where? It's loaded from lib systemmd system docker dot service. It's been enabled, and so here you will find your bin file, a binary file. That's where you will find the docker dot service. And main process id is this, and the process id name also dockered. Okay, so this is the service, and here you see the Docker socket triggered by, this is what I want to show you. Triggered by whom? This will be triggered by whom? Through Docker socket. Okay, and docs, here you will find docs and task memory total 1.2 GB, and C group. So it is used by whom? One is 2755 process ID user bin dockered. Okay, this is dockered. That's absolutely fine. Container.sock, and second one is host port 800.172. Okay, this one is Docker proxy proto. This is our client. This is our client. You see that, because 172 is our private IP of this machine, so it has become a client. And user bin Docker proxy 10383, and this is container IP. It's also same. Okay, so here this is how. So who are all part of this group? 2755 container.sock, and then client, Docker client, and then main process id is this, because this is a process. It's a process which is running, and it's been loaded here. It's loaded from this directory, and it is triggered. This will be activated. This will be triggered by what? Triggered by docker.socket. Now I'm gonna show you that. So now you have seen what is Docker client, and Docker client is in the same group of Docker process, the Docker daemon process, and then it's clearly mentioned the Docker daemon will be triggered by docker.socket. So now where is that docker.socket? That I'm gonna show you now. So let's enter into cd /var and then run. Let me say ls. Now you should find docker.socket. Here it is. You see that? So let's do ls pipe grep docker. You see, docker.sock. This one is s. Okay, this is neither directory nor this. It is a soft. Okay, this is a different type of file altogether. It's a socket type of file. It's a socket type of file. Other one is directory, other one is a file, whereas these are different. This is PID, process ID, and this is a socket type of file. Now a Docker client, and then Docker sock, and then Docker daemon. We have seen everything, and their connection also we have seen. And the second part, so Docker client remains same in our host machine. Docker daemon remains same in our host machine, but the Docker daemon will get requests, and will get requests from Jenkins server this time. It's not from Docker client. Of course, Docker client can also give, but even Jenkins server can also give. How? Through TCP, and then public IP, and then port number. So with this connection, Jenkins server can also access and operate your Docker daemon, and colleagues host can also operate your Docker daemon. It's like you have a car, and that car has a remote key, and then if you have your remote key, you can operate. If somebody has that remote key, they can also operate. So that's it. The car is our Docker daemon, and then a remote key is our docker.sock, or it's basically way of connecting to the Docker daemon, and then the entity who is operating is our Docker client here. So in second case, Docker client can be from your local machine, or could be Jenkins server, or could be colleagues host. Basically, that's what third parties can access the Docker daemon, the Jenkins server, and colleagues host connect to the host's IP address on port 2375 and can read and write requests and responses using that channel. So now, so before you open up the Docker daemon, you must first shut the running one down. So how do you do this will vary depending on your operating system. If you are not sure how to do this, you can use the following commands. So this is how: sudo service docker stop, or systemctl docker stop, systemctl either one, systemctl stop docker. So warning, stopping docker.service, because it's a process. See, Docker daemon is a process, and it also has a engine room. In that engine room, all the components will be stored. We have seen that var lib docker, but it can still be activated by docker.socket. Okay, it is stopped, the service is stopped, but through docker.socket it's still activated. Okay, that is one. And then if you have a systemctl based startup system, then you can use systemctl stop docker. If you do not have this, then you have to use sudo service docker stop, whatever way. But it's okay, whatever the way, you can stop it. And if this works, you should not see any output from this command. So pscf, that effectives. And then once the Docker daemon has been stopped, you can restart it manually and open it up to the outside users, because here I am showing the way to uh, open this Docker daemon to the outside users. Okay, so you say docker and then daemon, give capital H option, and you give the TCP and public IP and then port. So it will be open up to the external users. So this command starts docker as a daemon, defines the host server with the H flag. So obviously H flag is for the host server, and uses the TCP protocol, opens up to all IP addresses with the okay, that specific pattern, and opens on the standard Docker service port. So standard Docker service port is 2375. If Docker complains about daemon but not being a valid subcommand, try using the D argument instead. Okay, so you can connect from outside with the following command. Once the Docker daemon has been opened to the external world, so then it's time to connect to the this Docker daemon using this command: docker h option TCP, and here you have to give your host IP. Okay, this is the Docker daemon's host IP, and this is your host IP, the external user's host IP, and 2375. Basically, at from your host IP at this port 2375, you can connect. That you will need to do this from inside your local machine, because Docker is no longer listening in the default location. Okay, one example. So once it is done, if you are able to connect with that, so it's time for you to do some examples on that. In this, we are running docker run detached mode enter I and port mapping 1234 to this, and name of the container is daemon, and then image is ubuntu, and we with the closed one, one more port with closed one. So the D flag here, when used with docker run, runs the container as a daemon here. Okay, then I flag gives the container the ability to interact with your telnet session with P option, you publish 1234 port from the container to the host. That's the mapping. And the name flag lets you give the container a name so you can refer to it later. And finally, you run a simple listening echo server on 1234 with netcat, that is NC netcat server. So now let's specifically look into Docker client. So we have seen the complete whole architecture and we have seen the demonstration of that also. But now let's look into the only Docker client. Some of the facts about the Docker client. The Docker client is the simplest component in the Docker architecture. So it's what you run when you type commands like docker run or docker pull or docker push or docker build or docker tag or docker stop, docker start, docker rm, docker rmi. So on your machine, its job is to communicate with the docker daemon via http requests. So in this slide, we are going to see how you can snoop on messages between the Docker client and the server. You will also see a couple of basic techniques to do with port mapping that represent baby steps towards the orchestration section later in this course. So, and a way of using your browser as a Docker client. So this is your host machine. And as usual, we have seen this diagram. In your host machine, it will be split into two components, Docker client and Docker daemon, and both will be communicating using request and response architecture of HTTP and RESTful API. So this is your Docker client. When you issue a Docker commands on the command line, an HTTP request is made to the Docker server on your local machine. The Docker server carries out the command and returns an HTTP response, so which is interpreted by your Docker command. So how that will be interpreted? Who interprets it? See, whatever we have seen in our previous slide, now that we are digging deep. Previous slide we have seen about one tool called docker.socket. Doc.socket. We have said it's going to do something. Okay, it's going to transfer the message, it's going to connect, it's going to trigger, but how? That I am going to show here. It's like dwelling in depth. Dig more, dig it like dig it like that. Okay, so here is a Docker client. Let's take one example. HTTP request and a response is made, then the domain Unix domain socket that I have shown you. Okay, just a minute. This is comes into the picture. So what it does is, okay, before that, so what it does is it makes communication happen via a Unix domain socket. It functions here as a file, as a tool, as a GNU utility. You can write to and read from as you could do with a TCP socket. Okay, you can use HTTP to communicate with another process without assigning a port and use the file system directory structure. That's the power of it. So this is the one is making all these things possible, because when you use HTTP protocols, HTTP request response, you require a port mapping. You require a ports to exchange the data to make all this possible. Without assigning port, your domain socket helps us to make this communication possible. I have shown it to you earlier, and if you want, I would like to show it one more time. No, this is here, sorry. You could see that docker.sock, that's a domain socket like TCP socket. Then on other side you have a Docker server. So Docker server is a standard application server written in Go that returns an HTTP response. So Docker daemon, anyway, we have seen. So that's how it works. So that's how a Docker a .sock makes these things possible.